Hello, everybody. Welcome. Didn't mean to wake you up. Sorry. So this session is the Exchange Client Network Bandwidth Calculator version 2. Fundamentally, this is an evolution of where we were with the version 1 calculator. So this is, there are no major changes in here. This is really the addition of the new 2013 client stack. Some adjustments in how we did calculations previously, some refinements over that. So what I thought I would do today, previously I've done sessions talking about how to use the calculator, and apparently they're quite boring. So what I've done instead is talked about how the calculator works, so how we get the data, how it works, some comparisons of the new clients, so what that looks like compared to some of the old clients. And then we'll look at all of the client data that we have and kind of how the clients stack up against each other. And then I'll give you a quick drive of the new client, the new calculator. We can take a look at that, and then we'll dive into some Q&A. So the history for the client bandwidth calc is quite intriguing. Well, it is for me anyway. But there's been a few attempts to do it over the years. So does anyone remember the 2007 white paper, the client white paper that talked about Outlook Anywhere and this kind of stuff, and it talked about the bandwidth use? That was kind of our Bible for quite a while. But in 2009, during the Exchange 2010 TAP program, we had a number of fairly large-scale clients that wanted to predict bandwidth worldwide. We had a couple of pharmaceutical customers that had Exchange servers in really remote locations, and they were very concerned about the change in bandwidth from moving from Exchange 2003 to Exchange 2010. And so we used that white paper, and we did this in a lab environment, and we started to validate the results, and we became aware that the results that we were predicting from the white paper were not exactly what we were seeing in production, right? So we started to become aware at that point that the data in that paper, from a network perspective, was not exactly what we were observing. And that led to a whole bunch of discussions with the Office 365 dedicated team who were following a similar path, and they were discovering that there were also discrepancies in the data from the same predictions. At that point, there were a few other calculators that were kicking around within Microsoft and out in the community, with various different approaches in using Excel formulas to do this, but they were all based on the same source data, which came from that white paper, which said things like OWA was 10 times heavier from a bandwidth perspective than Outlook. And if you've ever used OWA and Outlook, you'll realize very quickly that that's not the case, right? That's not even close to the case. So we traced that back to where that source data came from, and actually it came from LoadGen. And LoadGen simulates the way the clients work and doesn't actually, it's not actually doing the same thing as the client. So that was kind of the root cause of that data. And that led to us doing this again from scratch. So coming back to what the calculator's for, I mean, predominantly it's for sizing our network links. And way back in the day, network links were never that important. I mean, they were always something that we were concerned about. But the move to the cloud and also consolidation has led to far more emphasis on how much network utilization our clients are going to require. And the classic one here is almost, I think, probably in the last 5 years, every program of work that I've been involved in, consolidation has always been part of that. It's to take, distributed systems, servers out in various different places, and try and bring them back into core data centers where they can be secured more appropriately, managed more appropriately, benefit from economies of scale. Essentially the DAG model drove that as well. So if we have a slightly larger DAG, we can have more mailboxes. It's more efficient for us to do that rather than have these little servers dotted around the place. And that always brings in the same question. How much network bandwidth do I need to support my clients if I have the Exchange server in a remote location? So, and the decision process here is always very, very similar. It's around, well, can I move my workload to a central location without having to incur unnecessary network costs. So are my network costs for consolidation going to be greater than the savings that I might make from consolidation in the first place? So, it doesn't make sense to try and consolidate if my network upgrade costs are going to be astronomical. If I need to spend $1 million to upgrade my network bandwidth, but I'm only going to save $20,000 from moving the server, then it's probably not a wise decision to take. But this leads to customers wanting fairly precise prediction data. This is something that kind of hit us in 2010, and actually this was behind a large part of the work for the bandwidth calc, was the realization that load balancer sizing is predominantly a function of throughput. So if you go and talk to load balancer customer or load balancer vendors back in 2009, before Exchange 2010 was around, they would talk to you about this idea of SSL TPS transactions per second, and that was how you sized your load balancer. And that was based on the way websites work, Amazon, for example, or wherever it may be, banking websites, based on this idea of the load balancer being busy from a CPU perspective as it established that secure SSL connection. When we start to push workload through it like Exchange, we do fewer of those. Those SSL TPS values, they're quite low from an Exchange perspective, but the throughput value is quite high. So what we see from that is that we potentially don't have a high TPS, but the throughput we put through the load balancer drives its CPU up, and that's what helps us. That's what essentially limits us from a throughput perspective with a load balancer. So we found that it was a useful tool to help understand how big a load balancer you were going to require. And also, and then this is coming back again now, where many customers are approaching mobility. So you already have Outlook deployed, you may have some OA out there or whatever it may be, and you've probably got some BlackBerry or something in the environment, and then you want to deploy Surface or some of the, you want to take your Dell tablet that you received today, and then, that's great, and everybody wants to deploy them. Well, what impact does that have on the network usage? Okay, so if you're going to increase the number of the devices, many of my customers are now operating 3 devices. So they'll have their Outlook, their desktop client, they'll have some form of mobile phone, and they'll have some form of tablet as well. Some just have a desktop, but there are many customers and many places now where having a broad range of mobile devices is important, and clearly a lot of these are connected over the internet. So being able to understand the requirements on the network are, again, really, really important to understand how to progress with those kind of programs. So I'm just going to take my watch off because it's irritating me. I'm easily irritated, so there we go. So how does it work? So back with the white paper, what we would do is we'd work on this concept of kilobits per second. And what we would do is we'd say, well, how much data do we need to transfer in a day for a client? And then what we would do is we would average that over an 8-hour period, and then we would double that to account for the peak. And what that led to is the assumption, essentially, that the network usage for a client was constant through the day. And that was how we did things back in 2007. And clearly that's not the case. If you ever observe people in a building, and you ever observe customers coming in and out in an area, then you will notice that whilst work may begin for some people at 6 a.m., others it doesn't begin until 10 a.m. And some people have lunch at 12, some people have lunch at 1, some people never come back after lunch, right? So there's a whole variation in how people work. And that leads to this concept of what's called a usage curve. And I'll come on to the usage curve in a few minutes and how we use that. But fundamentally, the way we predict the requirements for a client or a bunch of clients is we work on the quantity of data they need to transfer in a period of time. And we usually work on a day. And so what we would do is say, okay, Outlook 2013, we take the usage profile for the bunch of users in question, so how many messages they're sending and receiving in a day, and how large, what the average message size is. And then what we do is we calculate this quantity of data. The next thing that we do, and this is kind of new for the calculator that we released back in 2011, which is where this calculator is based, is we then split that up and we calculate it based on a per hour basis. So what we do is we start to look at what's happening in that user environment on a per hour basis. And the next thing we do is we calculate the bit rate. So this is the kind of terminology the network teams are interested in. This is the kind of the network speed, the kind of megabits per second or kilobits per second of the link. And we calculate how much per hour, what the kilobit per second or the megabits per second rate is that we need to support the data. And then what we do is network traffic is slightly strange in that it's very spiky. If you look at a network trace from any kind of network device, you don't see these kind of nice smooth curves that we always predict, right? So you see the calculator predicts this beautifully smooth curve. If you dive into that, it's really spiky. If you go in and look at it on a per second basis, it's flat out 1 second, almost nothing the next second, really busy for the next 2 or 3. So it's very, very spiky. And so what we do is we adjust the bit rate that we calculate for the average across the hour to account for some of those spikes. And this is kind of where the magic comes in for this calculator and where this data comes from. We realized after we'd come up with a new model of calculating bit rate based on this per hour basis, we realized that the source data that we were using to predict all of that stuff, so when we're trying to predict how much data a client needs to transfer in a day, whether it's a phone or Outlook or OA, we needed to be able to predict that amount accurately. And the source data we had, we knew was essentially unreliable. So we devised this process in the lab of automating the clients. And the way we do it is we connect 2 clients into 2 mailboxes on the same Exchange server, and we automate them doing a particular task. So in this case, user 1 is sending an email to user 2. And we do this a lot, hundreds and hundreds of times for different types and sizes of message. And we will then do netmon traces of the clients and of the Exchange server. And we're looking to observe how much data is moving, how many bytes of data are moving from the client to the server and from the server to the client, given various different tasks. We do it many times, and then we average across that. So we can start to predict what the byte requirement is going to be given a certain action in the client itself. Now, as you can imagine, this takes a long time to run. And this is partially why it's taken a while for us to get the calculator out with the 2013 data. For essentially each client takes a few days, takes 2 or 3 days really to run through all of the different tests, generate all the netmon traces that we need, and then we convert those netmon traces into predictive algorithms. And I'm happy to say this time around, to get the calculator out in time for MEC, this guy gave me a hand. So this is Gabi Viella, and he has been working, that's a very weird picture of him actually, but he has been helping me out hugely with his lab and lending me time to automate the client testing. So he's behind a huge amount of the data that we're using right now. But fundamentally, that process is behind the accuracy and the ability of the calculator to work the way it does. So once we've got that, we produce this thing. For each of the clients, what we're looking to do is figure out how message size impacts the amount of data that we transfer across the wire. And initially, we believed that this would be reasonably similar across the clients. And as we started to test, we realized it wasn't. So we have these kind of formula for every single client and each protocol that the client can use. So think, for example, now about Outlook, right? So Outlook 2013 can connect via MAPI. It can connect via Outlook Anywhere, via RPC. It can connect via Alchemy, so the MAPI over HTTP. It can connect via POP. It can connect via IMAP, and it can connect via ActiveSync. It's the same client, but it can connect over all of those different types of protocol. For many of those protocols, it can connect in online mode or in cached mode. And the network usage and the network profiling for every single one of those combinations is different. And the behavior is different. The latency requirements are different. This linear curve, which we're showing here, I think is for Outlook Anywhere. We're looking at the numbers. But it's completely different for for Alchemy, for the MAPI over HTTP. It's different for IMAP. It's different for POP. It's different in online mode. If you think about the behavior of an online mode client, for example, if I just connect my online mode client into my mailbox, it doesn't really download a great deal. All it receives is a notification to say, there's a new mail in your mailbox. It doesn't matter how big it is. If it's a 10 megabyte mail or a 1 gigabyte mail, it doesn't matter. I'm not actually going to drag it over the network until I click on it. But if I have a cached mode client, it's going to download it. As soon as it hits my mailbox, it's going to bring it down and start to cache it down to me. So the behavior of the clients is incredibly different as we progress. So we do that. Oh dear, I got a bit carried away with PowerPoint, I think. Is it going to finish? Yay, great. So we do those calculations for these 9 areas. So we look at message received, and we look at a predictive algorithm based on the usage profile for how, for you've received a message, how many bytes of data do we need? For the OAB download, for the clients that need to do that, how do we predict that? And that's tricky if you think about it. So OAB download is a function of OAB churn, so changes in the directory. So we spoke to many customers, and we started to look at how many directory changes, and we started to look at their OAB diffs. So we started to look at how big the changes were on average. So we started to come up with some values for that. OST resync. Now, OAB download and OST resync in that white paper in 2007 were not even considered. And OST resync actually accounts for a significant portion of data. OST resync, the concept behind it is that you have a laptop, and that laptop is not going to last forever. At some point, it's going to be replaced. The hard drive may fail. It may get upgraded to a different operating system. And at the point that happens, you're going to reinstall Outlook. You're going to type in your details, and AutoDiscover is going to beautifully connect you back to your mailbox. And then Outlook in cached mode is going to go and drag down a portion. In 2013, a portion of your mailbox. If you've got a 2010 client, it's going to bring the whole client down, or the whole mailbox down, rather. And you need to account for that. This is a frequent task. This is a frequent thing that happens. Hard drives fail pretty regularly. Support teams frequently will create a new profile for a user if there's a problem. And that triggers an OST download. So this is an area of bandwidth that we didn't really think about a great deal before, but when we started to model it, this can account for 10 or 20% of the bandwidth. If you've got a large mailbox, let's say you're allocating 10 gig mailboxes or 20 gig mailboxes to people, every time you do a resync, that 20 gig is going to come back down. So that has a big impact. For the 2013 client, we've now got that slider for how much data you're going to synchronize back down to Outlook. So we had to come up with a new model for the 2013 clients to allow us to deal with that, and that's in the calculator, so we can deal with that. Message sending, so the average message size and the quantity of messages that you're sending, again, can impact. And it's important to realize that the bandwidth requirements are asynchronous. The amount of data we need to bring down to the client is different to the amount we need to upload to the server. And as Exchange guys, we're not normally concerned about that kind of stuff, but network guys are really anal about that kind of stuff. They get very excited about what goes up and what comes down. Availability, and this was really interesting as well, because if you think back to availability via public folders, do you know what? That's really efficient from a network perspective. I mean, it sucks from a everything else perspective, but from a network perspective, it's really efficient. It's very, very, very densely compacted data. When you go to availability, that becomes SOAP-based, and it's pretty chatty. It takes quite a lot. So we had to come up with a mechanism to deal with that for all the clients as well. And that varies not on message size, but on number of meeting recipients. So if you've got a meeting with 10 recipients, fundamentally it takes 10 times more data than a meeting with one. You have a meeting with yourself. So I don't know, let's say a meeting with 2 recipients, and a meeting with 10 recipients. The 10 recipients takes, 5 times more network bandwidth, because you've got to deal with all of these availability requests coming back. So we needed to plan for that as well. Item deleted, we added this in because we didn't know what, in many of these actually, we added these columns into the calculator because we thought they might be useful. We weren't really sure. And item deleted is one of those. And we thought that might have a network impact. Turns out it doesn't. It really doesn't matter which client you're on. When you delete an item, It really doesn't have a dramatic impact on network, but if it does, we can deal with it, but it doesn't at the moment. Item read is another one that we weren't sure of. It turns out it doesn't have a big impact. So when you go from read to unread, a very, very small amount of network bandwidth. Auto discover can be quite chatty in certain cases, but actually, as it turns out, as a whole, it's not a huge amount, but it is there for us. And log-on traffic. Log-on traffic's really curious in the fact that it depends on the auth protocol that you're using. Now, we assume the defaults in the calculator. Although it can vary, it's still not a huge difference. So we assume that it's the standard client authentication type. Although we will change that. Because there are some scenarios, and we'll talk about Alchemy later in the MAPI over HTTP, but it varies in the way it behaves depending on the auth protocol. So for each one, and again, so when people have been emailing me saying, when's the new calculator available? Why is it not available yet? What are you doing, you lazy sod? Basically, what we've been doing is thinking about this stuff, right? So we go and gather the data, the sending and receiving stuff, and we figure out the core principles of how the client behaves, and then we start to figure out this other stuff. And quite often this is going back to the engineering teams, asking them what they think, looking at how the client behaves, trying to come up with some kind of linear prediction for the client. Because we need to, for every single one of these things, we need to come up with a linear prediction that is reliable and that we can essentially predict in the future how the client will behave. So once we've got that, we've taken all those 9 things, we've got our kind of linear curve, and we can then start to predict the quantity of data that we need to move per client. And then that comes back to this curve. If you ever look at utilization curves for a bunch of users, they typically look like this kind of double hump thing. Actually, Boris Lokvitsky is behind a lot of this. Boris and I worked on the mathematics behind this a couple of years ago. But the thing that's interesting about this is the morning curve is quite steep, and then it steadily kind of drops off as people skive off home early. And then you get the odd few that just never go home and kind of stay there for a while. But the calculator, essentially what the calculator does is it predicts, we generate this curve, and we figure out what this curve is. And then what we do is we take that chunk of data, and we work on a percentage basis. So we look at each hour, and we then calculate what percentage of that total data we need to move, we've got to move in that hour. So if we've got, like, I don't know, let's say 1 gigabyte of data we've got to move, and then 10% of that we've got to move in one of the hours, then we know we've got, you've got that 10% of data to move, and we can then calculate the bit rate needed to do that. So the nice thing about that is it gets away from this assuming that people do the same thing all day, because we know they don't. And it also allows us to be a little bit more creative with this curve. A second reason for this curve is it allows us to combine workload together from different time zones. So one of my customers hit me when we first came up with the bandwidth calc. They hit me with this problem that they had where they'd done pretty extreme consolidation, and they had workload from different areas of the globe. So some users were +5 hours from the data center, and some were -5. And that gives you a really different shaped curve, right? That looks a lot different to this. That looks, essentially it kind of starts to flatten out the day. But one of the interesting things that it does is it reduces the peak, because you've got the same number of users, but they're now spread out more evenly through the 24-hour day. Now, I'll show you the calculator shortly, and I'll show you a little demo of how the time zone stuff impacts that. But it was this investment in using this usage curve that allows us to do that and allows us to deal with pretty intense consolidation. So, does anybody want to see some new data from the new clients? So how many people have looked at MAPI over HTTP so far? Is anybody using it in production yet? Yeah, all the hands go down really quickly. I'll wait for somebody else to test that, and then yeah. So, before I get into that, actually, what I find fascinating about this is the reason that we did it. So I was in some exec briefings today with Kareem, who was talking about this. And it turns out that RPC hasn't seen any innovation really in a long, long time. So 10 years or so since RPC had any significant innovation. And, there were some inherent problems with authentication when we use RPC. And if you think about the last time we innovated in that space was when we brought in Kerberos in 2000. And if anybody is looking at Office 365, one of the things you will quickly become aware of is that Auth at the moment sucks with 365. If you want single sign-on, you want seamless authentication to the service, marketing, yeah, we've got it, single sign-on, it's all great, well done you. The reality is it isn't, right? It's not as great as it should be. So the investment in the change to this is around modern authentication protocols that it can enable for us in the future. So with that, this is the data that we got. Now, I'll explain this because it's not immediately obvious, but the chart on the left is receiving. So this is, what this shows is Outlook 2013 in Outlook Anywhere versus MAPI over HTTP. And you can see they are virtually the same. There's very little difference. So it's about 1% cost for you using MAPI over HTTP. From receiving client. And the majority of the traffic is receiving for clients. On the right-hand side is sending. Now, there's a big difference here. Well, it's a clear difference, let's say. It's not a big difference. And that difference is to do with the way we authenticate when we make the calls. When we send, we do more stuff. There are more calls that we make, and we have to authenticate to the server more times. And it defaults to using Kerberos in this case, which is a bit heavier itself. But it's important to realize when we're looking at this that it's actually a fairly small quantity of data. So if I look at that, it's about 15 kilobytes per message heavier on the network. Which, when you're looking at it, and this is looking at it on a per message basis, so that's kind of why the chart looks the way it does. We were really zooming in here and looking at the difference on the clients. When I show you the relative client data, you'll see the impact is much less. But this is zooming in right on that piece for sending. The expectation is that actually this may change in the future and it may get a little bit closer. But fundamentally, the cost is pretty small. We're not dealing with a huge cost in moving to MAPI over HTTP. So this is the fun slide, and I debated putting this in. It's a bit of an eye chart, but I kind of like seeing this. This is when I'm doing new client data, this is the thing that I kind of always want to get to. I want to get through all the data and get all the algorithms done so that I can look at this. And what this shows is how the different clients stack up from a network perspective. So you'll see at the far left-hand side that you can't read because it's under the thing there. That is Outlook 2011 Exchange Web Services. That's the Entourage replacement Exchange Web Services client. The reason that sucks is because there's no compression. There's absolutely no compression in that protocol. So, and it is just very, very heavy. And you can see that, actually. You can see the way the client behaves, and you can see the way it deals with, you see that if you have a lot of Mac clients, the network usage is very high. Then you get a whole bunch of clients that are about the same. They're the cached mode clients. And what's interesting about that is it doesn't really matter whether they're Outlook Anywhere cached, whether they're Alchemy cached, whether they're MAPI cached. They're behaving in basically the same way. They're downloading the same quantity of data. Now, the sending and receiving, if you actually compare them in those detailed charts, there are differences. But once we bring in OST resync, OAB downloads, availability, auto-discover, all of the other parts of the kind of bandwidth, the data that we need to shift, they start to kind of level out. And actually, those differences are fairly minor. So as we're thinking about scaling, running Outlook in cached mode is the heaviest mechanism from a network perspective of using Outlook, but it's also the most protective. So if we're running in cached mode, it protects us very, very heavily from network latency and any kind of problems that we may experience. So although the cost is the highest from a network perspective, it also protects us the most and provides the best user experience. Then we've got a couple. So the Outlook 2003 is slightly lower. And there are some reasons for that. And it's to do with the format of the messages, to do with the way the client formats the messages, and it's a little bit better at doing that. So if you want to run in cache mode, then and you're really obsessed about this, then Outlook 2003 is the the best way to do that. And then the next bunch of clients are what you tend to refer to as online mode clients. So these are clients that connect into Exchange and provide a kind of rich function and features, but they don't download the files automatically. They don't download your emails automatically. And you'll see in there, the one at the top left is Outlook 2010, MAPI Online. OA clients, Outlook 2013 in OA Online and HTTP Online as well. So you can see these are pretty similar. OA 2013 has got some benefits. OA 2013 is pretty good from a network perspective. It's better than the previous versions. And a large part of that is this, the inline editing and the way they've changed the kind of UI. A large part of it is down to that. So when you come to open a new message, for example, or create a new message, you're not opening a new IE window. Every time you do that, that's a new TCP connection, which means new auth, which is all traffic. So the 2013 OA client is much better. Now, what's curious about this, did anybody spot where OA 2013 offline is? Works just like a cache mode client. Now, there's some interesting behavior with OA offline. If you observe what the client does, it has a TCP connection in the background, which synchronizes the offline store, so it's bringing the mail items down. There are limits. There's about 150 items that it's bringing down. But once it's up and running, it's in this churn mode, so it's dependent on how many messages you receive, and it's pulling things down, and it's in its thing, downloading stuff. When you go and open an item, where do you think it pulls that item from? It gets it from Exchange. So we download the items, and we have them in the HTML store, and that's great. When you go and open a new mail item that's just been received, or one from 10 minutes ago, we don't open it from the offline cache. We open it from the store. We open it from the offline. It's a good question. Yeah, why? Yeah. So I don't know. So, but we do. So having discussions with engineering right now about whether that is or why that is the case. But it's curious. I mean, if you think about it, the actual network penalty is not that big. I mean, it's working like an offline. It's working like a cache mode client. The bandwidth requirement is roughly the same as a cache mode client. But curiously, it could be a bit better. It could be that we could make that some improvements there. So Jeff Mealy and I are going to start talking to engineering and see if we can figure out why that decision was taken and if we can improve it a little bit in the future. But it's one to watch out for. The other interesting thing here, I think, I find everything interesting, really, I'm easily pleased, but the Windows 8 Mail client we included. And how many of you have Outlook and the Windows 8 Mail client configured on your Surface devices? I see. I'd expect nothing less from you, my friend. But it's really common, right? People do it. And amazingly, that doubles the network bandwidth you need, right? Because you've got two clients that don't really know much about each other. And so I have a customer at the moment that used the bandwidth calc to predict and then told me it was rubbish and it was all terrible. When we went to look at what they were doing, they're actually doing this automatically. They're configuring both clients automatically for their end users because they've got these new Slate devices. And they only accounted for one of these in their bandwidth data. So that's one thing to be aware. I mean, be cautious, be aware of what you're doing. When you're doing this kind of planning, beware that this kind of stuff can happen and people can do it. The best platform by far is Windows Phone 8. So Windows Phone 8, in fact, Windows Phone 7 is very, very similar. Now, you will notice here that I'm not including Android, iOS, whatever else is out there these days. And the reason for that is I got told off by the LCA because all of these devices have a EULA in them, which says, thou shalt never divulge performance information about the device. And apparently, telling you guys how much network bandwidth each one requires is breaching that, so I'm not allowed to talk about it. But fundamentally, iOS and Android work from a network perspective roughly the same as a cached mode Outlook connection, and that will surprise pretty much everybody, I guess. And the reason behind that is what both of those clients do is if they are well connected, so they're on a wireless connection or they're on a 3G LTE connection, something like this, what they do is they download the plain text version of the mail message first, and then they go back and download the rich HTML and all of the attachments in the mail message into the phone. And you will see iOS is, in fact, both iOS and Android do the same thing in that they they'll only do that if they're well connected. So if you're connected over, for example, a very, very slow radio connection, they won't do that. Neither of them will tell me what that cut point is, but roughly speaking, it's about where 3G was. It's kind of once you're up to like 5 megabits, something like that, they'll attempt to go and do this stuff. But because they're downloading each message twice and then going back and downloading all the attachments, if you think about it for a minute, they're behaving very similarly to cache mode Outlook connection, and that's roughly where we see. So I can't tell you that that's exactly what it is, but it's approximately there. They are quite heavy from a network perspective. So how do you use it? What are the processes we go through? It's very similar to the storage calc. The first thing we need is user profile data. We need to know how many messages each user is going to send and receive per day. And we need to know the size, the average message size. Now, what's interesting here is the average message size has a very, very limited impact on the storage calc. If you change the message size in the storage calc, it doesn't change the IOPS, probably doesn't change the storage that you need a great deal. So you end up with certain customers I've seen guess this value. They're not really sure. It's about 100 KB probably. And they're fine with that, and that's been fine for storage. It is not fine for bandwidth. The bandwidth that you consume is linearly related to the average message size. The larger your average message size, the more bandwidth you get. If you are 20% out with your average message size prediction, your end bandwidth prediction is going to be about 15% out. So it's very, very, it's a very important metric that we need. And there are some other things that we're interested in as well. The average mailbox size seems an odd thing to be interested in for bandwidth, but it impacts how much data we need for OST resync. The larger the mailbox is, the more stuff we're going to need to download when those clients are resynced. Average recipients per meeting, again, it seems an odd one, but it's to do with availability. And it's very difficult to determine this, so we guess, right? So we guess at 3 in the calc, and it seems to bear out roughly speaking. But if you have customers or yourself, your organization are very meeting-centric, very large organizations, lots of large meetings, it may be you need to go and tweak this a little bit. And there's another interesting one here, the online mode attachment read percent. This is accounting for online mode clients and how often they're going to read the same mail message, because we need to determine how many times they're going to download that. And the final one is new for 2013. It's this mail to keep online. This is the slider in Outlook 2013, which says, I only want to have in my OST file the last 6 months worth of data. And then we use that combined with the average mailbox size and the messages sent and received per user per day to determine what that looks like. So we try and predict essentially how big your OST file will be if you select 6 months or 12 months. And then we use that for some values. The next thing we do is we go into the client distribution. We go into the client mix sheet, and we enter in their site names, the client type, the client numbers, the concurrency, and the time zone. And that allows us to predict this shape of the curve. Oh, hey, there's a question here?
Is there any tool to automate to gather this information automatically?
No, there isn't.
Usually the administrator.
Yeah, so there are some scripts to get some of this. People like your Quest message stats will gather some of this. Some of this requires on local knowledge and talking to people within the business and trying to get a handle from that. So some of this you don't need to change. So, for example, if you don't know average number of recipients per meeting, then just leave that as the defaults. There are some of these things that are very important. Average message size is vital, and so are the sent and received per day. Yeah, well, so the rest of this stuff you ought to be able to get, to be honest. So some of these values, like, for example, mobile client attachment read percent, we've worked with many people and we've worked with lots of customers to try and determine what the average value should be. So you can probably leave those. There's an argument that we're going through at the moment whether we actually surface them in the calculator and let you change them or hide them from you so you can't change them. This version of the calculator that we have right now opens them up and lets you change them. And we're currently thinking about, well, do we highlight cells that are more important than others? So, here are the cells that you absolutely must fill in, and these ones are, you can do if you wish. So we're still in an early phase of thinking about that, but some of these are easy to find or relatively straightforward, and some are more difficult to. Yes. Yeah. So you would run some of these. You get via script. So there's the message stats script. Quest message stats again. We'll get some promo DAG. We'll get some of these. And then once you've got them, you enter them into the calculator manually, and you don't have to. You just have to do these for each profile. So you don't have to. It's not a lot of typing. Only about 4 of these. And then once we've got that, we then analyze the predicted results. So I kind of want to get to the point where we can get the calculator up. So what's new? Well, Outlook 2013 is new. So we've got some data around MAPI, Outlook Anywhere, and MAPI about RPC. So we've got some new data in there for that. The Windows 8 Mail client, and this was really curious, actually. We weren't sure how this was going to behave or what it was going to be like. So we automated that. What I find curious about this is that there are many devices out there, which this is probably the primary mail consumption client. But not many of my customers deploy this and then decide not to deploy Outlook. So every Surface device out there and all these kind of little tablets and the little Dell things that we were all given, people will put Outlook and the Windows 8 Mail client on them, and people will switch between them depending on whether they're using a keyboard and mouse or whatever. And so we included it. But it was the thing I wanted to get across to this audience was, beware. When you have those devices, it's very common for both to be installed and running. And then we looked at OA. So we included the OA 2013 stuff, the online mode, the standard stuff, and then the offline and the mobile. Interestingly, the mobile client is, we haven't included it in the configuration for clients because it's identical to the standard OA client. It is just surfacing the standard OA stuff, and it behaves in exactly the same way. And then Windows Phone as well. If you think back to how we generate this data, there's lots of automation. So we're quite a lazy bunch when we come to do this. So we don't like to, click a lot of buttons. So we write a script to do it. Some of these clients really don't lend themselves well to being automated, and it's quite easy to break them if you try and drive them too fast. It's quite easy to break them. So we learned a lot about how the clients work. So when is it due? So what I was going to do, in fact, what I am going to do is I'm going to upload it to Yammer. So I'm going to show you the version. What we're going to do now is we're going to dive into the calculator. I'm going to show you some of the new features and some of the stuff that's in there. But what I'm actually going to do is I'm going to upload the version of this calc to Yammer. Now, there are some caveats to that, so I'm trusting you all massively. And Ross will kill me if I do this and don't tell you. So. Network. Oh, I can't spell. I'm under pressure now. Sorry? Yeah? Is it? Next few weeks. So there you go. So you feel free to go and use that. The caveat essentially is that the data in here is not yet validated. So we have taken the same approach that we've done previously. There may be bugs in it. It may not behave the way that you expect. So take a look at it. If you're doing some planning stuff and you're curious about how moving to the new clients may impact your network usage, by all means take a look at it. Give me some feedback if you think it sucks or you want to have something changed. And yeah, we'll work with you. In the next few weeks, there are a few large customers that we have right now that are in network planning phase and have some validation data for us. So we're just currently working with them to validate the results. So with that, I'll bring up Excel. So this is the version 2 of the calculator. This is the actual version that I've just uploaded to Yammer. And you'll see the sheets at the bottom. There's kind of the input sheet, the client mix sheet, the results sheet, data tables, and then the version changes, which is just the kind of the version control sheet. You need to begin on the input page. And you can see here there are some things that we can configure about the organization. So working day, bandwidth, headroom, we should leave that as 100%. Mobile device days to sync. So this is kind of, when you configure your mobile device, how many days of data are you going to sync down to it? So there's some global things that we can set there. The interesting stuff really is in these profile bits. So this section here. And you can see here, so we need to do the average message size. We need to look at the messages sent per mailbox per day, messages received per day, average size, recipients per meeting. So all of the things that we spoke around before. One of the things, the number one problem that I have with people when they email me and say the calculator's broken is they do things like this. So where it says 2 in there, they put 2 GB. And that breaks the calculator immediately because 2 GB is not a number. And the calculator already puts 2 in there for you. So if you're using the calculator and you start to get value listed, so if I go in here and look at the client mix sheet and we pick a value, let's say, I don't know, 5,000 in there. We'll look in the results sheet. You can see here that we have some stuff, right? You can see it's got a prediction value and the chart, the usage curve has been created for us. If I go back in here and type in 2 GB, looks the same. Oh, what have I done now? I took that in the wrong space. How on earth is that working now? Is that one that I see that's wrong? Yeah, so you can see it's gone. The value's all gone to value from changing essentially changing that value from whatever it was to having the text at the end of it. So watch for that when you're using the calculator. Just be a little bit careful and be a bit cautious with that. So we fill in these different values. Most of this stuff is relatively straightforward. We are looking at highlighting to you which ones are more important than others, and some of these will probably disappear. In the version that we actually release in a few weeks' time, we'll probably get rid of some of these because there's no really good way for you to go and determine what the values are. So you just leave them as the default. So where that's the case, it doesn't make sense to surface them in the calculator. But because of where we are in the development cycle and where MEC fell, we felt it was useful to get it out to you guys now, so it was there and you could have it and give us some feedback. So that's where we are. The big new feature, I guess, down here is being able to change this mail to keep offline. So this is for Outlook 2013. This is the only client that will use this feature. It lets you change that value. And then what we'll also do here is I'm going to do a quick demo of the time zone issue because my customer hit. So they had roughly it was about 5,000 in each site. Now, if we go back and look at the results table, everyone here is in the same. Let me just change that a bit. So everybody here is in the same time zone. And you can see the peak value, the calculator's telling me that 23.26 megabits per second is required to support those 10,000 users. And we've got 5,000 in site 1 and 5,000 in site 2. when they're all in the same time zone. Now watch what happens if I go and change the time zone. If I go back here and change their time zone, so I'll put these guys, I'll do exactly what this customer had. Now what you can see happens immediately is the curve changes. And it's less than half of what it was before. Because although we've still got 10,000 users on the platform, and they're still doing the same stuff, they're using the service at different times. So this allowed us to be a lot more prescriptive, and where previously we'd have predicted the 23 megabits and said that's what you've got to have, the reality is that that's not the case. For most customers that I work with, and it's the same in the US as it is in Europe, the time zone shift isn't as much as that. It's a lot more subtle. You tend to see small variations. So you'll see, for example, a couple of hours. But even that will have an impact on the curve. So if I do, I don't know, like a -2 and a +1, you'll see the curve still changes. And the approach that we took was to support this, so we can then start to model different time zones around the world and how they impact. But you can see even there, it's still reduced it. Like it's gone down from 23 to 21. So you probably can't see that very well. I think you can see it clearly on that screen than I can on my laptop, actually. But that's kind of the idea. You will also see that we've changed the way the client mix sheet works. So we used to have everything on this client mix sheet. So we had all the results at the end of the sheet. And if we found it was just a bit unwieldy, that people were confused where the data should be and how to use it. So we've changed the way the mix sheet works, and we have essentially all of the clients will be defined here, and then all the results on the results sheet. And then you can type in names here, so you could put in like London, Seattle, I don't know. And then you could make these changes. Oh. What is Seattle now? -8. Hong Kong, I think, is plus. Oh, I don't know. I'm going to go +8. But then you can see you get these kind of really kind of freaky shaped charts, and they predict the network bandwidth. If you take a chart like this to the network team, when you've got multiple different time zones, they're far more likely to believe you that you know what you're talking about than if you go and assume that it's just this beautiful thing and everyone starts at 8 and leaves at 5. But you can see the impact from that. And you can also see here in the results table, we kind of have the same names and we start to break it down. We found this, so my job predominantly is architecture, and quite often we use these tools and I just copy and paste from here and they go into the solution design document. While we had everything on the client mix sheet, it was difficult. It was, it was a bit unwieldy to use for documentation, and we found that people were just generally confused. So that's a big change. You'll also notice here we've got this TCP connections and the approximation for that. And that raises a really interesting point that I want to talk about. If I go back to the client mix sheet, let's say we have this customer, let's say we have 15,000 users. Now the temptation here is to think about devices, 15,000 end user devices. Now interestingly, that's not the primary metric that we're interested in from a bandwidth perspective. Actually, it's mailboxes, because if you think about a device like this, I can connect to multiple mailboxes, and it's going to download them all at the same time. So I have one Windows Phone 8 device, but it's connected to 3 mailboxes. So it's the equivalent of 3 Windows Phone 8 devices connected to 1 mailbox. Okay? And that's something to be aware of. So many customers get really confused with this and will end up with under predictions. The values here need to represent the mailboxes that you're connecting to. And essentially, the sum needs to account for all of that. So a good example would be, I don't know, let's say you had, let's take a really simple example. Let's say you've got 10 mailboxes on your Exchange server and 5 devices. But every single one of those users has a primary mailbox and they connect to a shared mailbox. In the calculator, the value you will be looking to put in there is 10 to account for the mailboxes, not necessarily the clients. So it's important to remember that. Also, that helps us understand the TCP connections. So what you will see as well is Outlook behaves strangely in certain cases where it's tempting to believe that it's got a connection into, let's say, Office 365. So it's going to have like 5 or 6 TCP connections to access its mailbox. What do you suspect happens when it accesses a shared mailbox in Office 365? Do you think it reuses those TCP connections? It should, but it doesn't. It will go and create a whole load more. And so you can end up with scenarios where your TCP connection count is really, really high if you work on a device-centric basis rather than a mailbox-centric basis. So it's mailbox-driven when you're putting these numbers in. Now, the current documentation that I wrote for the calculator doesn't make that very clear. It's a bit ambiguous. The documentation that we put together initially doesn't really tell you which way to do that. But when we re-release this, we're going to have some new release documentation and a new blog that talks about that. But it is mailbox-centric. It's the number of mailboxes that are connected to devices, not just the number of devices that are out there in the estate. The other thing that I want to show you as well here is people always... what's that noise? Am I making a buzzing? People always complain and tell me there aren't enough spaces to add sites. So you can see here there are 19, and there's a little plus button down here which will extend the calculator down to 99. So there's enough, so you can define 100 sites in there. I haven't got the patience to type in 100 site names, so I figured that was probably enough. If you need to go more than that, then it's actually quite tricky to just start inserting rows. If you're an Excel genius, you could probably figure it out, but it's very easy to break the calculator. So if you need to go above 100, open a second calculator and have, use that as well. So, but it does allow you to do that. And it I haven't got any customers that are over 100 site that I actively work with, although I do get emails from people that do. So if you've got more than 100 sites, consolidate something. That's basically where I'm at. So you can see here, this version of the calculator that's gone out includes 2003. So you'll see there's everything in here. So we've got Windows Mobile 6, we've got OA 2007, we've got Outlook 2003. I'm curious from you guys whether you think that we should leave Outlook 2003 and Windows Mobile 6 in play in the calculator, given that they're kind of out of support now. We have the data. It's not really any problem. It just clutters the calculator. So if you take a look at it, if you want to reply back via Yammer, actually, I have no idea how to use Yammer, but you can see I've embraced it wholeheartedly today. So if you've given me feedback in there, I'm sure it will email me and tell me that you've given me a comment at some point, and I'll be able to get some comments back from you and figure out, whether we should leave that stuff in or not. Yeah. No, we don't support it against Exchange 2013 either. So, I mean, it pretty much sucks, but people use it, right? And
Well, they should.
Yeah. Yeah. Okay, I'll say you said take it off. I'll get rid of it. Yeah. And to be fair, this is the second version of this calculator today, and I've added them back in because I just kind of thought, well, we've got the data, let's let you guys have it, and so this one will include everything, and then we'll figure out whether we can it or not in the next few weeks. So feedback from everybody, and then like I said, there are a few customers out there that are doing pre-release testing for us as well. So we'll try and make a decision on that. To be frank, I'll probably just hide the columns in Excel. I'm probably not going to do anything exotic, so you can probably get access to it anyway. So there are a few other things that I wanted to look through as well. One of these things, one of the nice things that it allows us to do, so we've got these 4 profiles. So we've got user profile 1, user profile 2, user profile 3, user profile 4. I notionally named them light, medium, heavy, and very heavy, but they don't need to be that. That's not what you have to do. You could have, executives, call center, or whatever. And you can define all of these different values per profile. So you'll see that you can even define how much mail to keep offline per profile, the average message size, or you can define all of these different values on a per profile basis. When you then go into the client mix sheet, you can then choose which one's which. So you can get to choose whether it's light, medium, heavy, or very heavy. The primary metrics for bandwidth is the usage profile, messages sent and received per user per day, and the average message size. Average message size, as I keep saying, is absolutely crucial. And if you get that wrong, your predictions will be wrong. It is not the same as the storage calc, as Brian will I'm sure attest to. Yeah, thank you. So, in the storage calc, the average message size is important, but it doesn't impact the IOPS calculations. If you get it wrong, you could still end up with a valid storage solution. If you get average message size wrong here, your prediction will be wrong. The more wrong you got your guess for the average message size, the more wrong your prediction will end up being. And you can put multiples on the same line here. So, for example, in London, I could have my Windows 8 mail client, so I could say, look, I've got, 5,000 of those. I've got some MAPI cached clients. I'll go and get rid of those too. And the calculator starts to accumulate all of that stuff, and will predict it for that one site. So off we go across, and I go into the results table. And you'll see it gives me a prediction for London. And then this chart is showing me what it looks like on what the prediction looks like. Yep. Yes.
Android and iPhone besides the can you use that 2003 area you have to account for them?
Yeah, you could do. I mean, I'm not going to tell you what to do with Android, and I'll probably get arrested. But if you treat them roughly like a cache mode client, so, and I mean, fundamentally. Yeah. Yeah, and it will skew your TCP connections, but it's the easiest way to account for those clients. And so we can do that. What this chart gives you a consolidation of all of them. So this would be, if all of those clients were hitting the load balancer, this is kind of where this is what it would look like on the load balancer itself. And if you scroll down to the bottom, it's going to give you this consolidation of all of them. Now, so sometimes this makes sense. So if you're planning network bandwidth for one data center, for example, then you would fill in all of the different sites that were perhaps consolidated into that data center. You would then be able to plan the WAN links that were coming in, and then the primary, this consolidation value would be the network usage at the load balancer, so what was happening at that point. Sometimes it doesn't make sense to do that. So sometimes you'll be planning for multiple different areas, and for that, I have multiple different calculators. So, for example, if I had consolidated areas in, New York, and I was having data centers in New York and Hong Kong and in London, I'd have 3 calculators for that. I'd open a calculator for each one of them. I'd then look at all of the sites that were being consolidated into each one, and then I would treat them as one predictive unit in the calculator. So I'd have a different calc for each one of those. So that's the kind of calculator done, really. There's this section here called the version change. This is this section called the data tables. People ask for this. I don't know why. I don't know what they do with it, but I had a number of customers ask for it. And essentially what this breaks down is the data quantity per day per client. So you can see here that the Outlook 2011 EWS for a light profile client needs 4.5 megabytes or 4.3 megabytes of data per client per day. I don't know what they do with that, but I had enough customers ask me for it that I included it for them. Because we've got the data, so we chose to surface it. So you can go in here and have a look and see. It's pretty useful to see how the clients compare. So you can start to see how they stack up. This calculator has also been useful in certain circumstances where clients have said, look, I have, an exec, and he's going off on a round-the-world cruise, and he's going to be on a SAT connection for most of the day. What should he do? What kind of client should he use? And that gets quite tricky because it's not just about the end user experience, it's about the cost. So if any of you've roamed, there's a lot of Europeans out here, if you're roaming on a data charge, it's not necessarily just the user experience you're concerned about, it's the cost per megabyte. So if that's a primary concern, then going down to the bottom of these tables and saying, hey, great, I could switch his client over into Outlook 2013 in POP or IMAP, or I could use the Windows 8 Mail client solely and switch off Outlook for him while he's out there. So it helps you have some of those discussions as well and compare how the clients are. So with that, I'll go over to Q&A. I think they're going to open the door now and kick us out. So if anyone has any burning questions. You could use Yammer. I don't know how to use Yammer, I will tell you that now. So I don't know how I'm going to respond to them. But if you would like to try that, I'm happy to go through that with you. Or feel free to speak into the microphone. Question? No? Just bathroom, yeah. Cool. Thanks, everybody. Thank you.
Neil, I had a question just real quick. Riley, did you show the 365 drop-down?
I didn't show that, no. So that's still there. The 365 drop-down is still here. Essentially what the 365 drop-down does is if you try and change this to scheduled plus free busy, so public folders, it will warn you that that's probably not a great idea because we can't have that. And also it removes a few of the clients. So it starts to highlight some clients that are not supported or not recommended. You will see that it takes off the online mode clients. I've left the 2013 08 online mode client in there at the moment, but I think that's likely to go as well, just because the client experience absolutely sucks. If you want to see how bad this is, go and have a bash. If you're in 365, it's not a nice experience. So that drop down there just kind of marks a few of the clients offline for you. Yeah, it is, but you're not accessing it so frequently. The idea being with the archive that you can go and get access to that, but you know, you're not doing it as frequently as perhaps you would do your primary mailbox. And also we don't size. We're not doing network sizing for the archive folder at all. And the reason behind that is because your new email is being delivered into your primary mailbox. So what's driving your network bandwidth is what's happening in your primary mailbox, not what's in your archive. And the concept of the online archive is you're going to get stuff infrequently from its old stuff, and you're going to go and get it infrequently. So sure, when you do go and get it, it's additional bandwidth, but the idea and the concept being you do it fairly infrequently, so it's not going to have a large impact on the bandwidth requirement for the org. So. Any more questions? Is everyone falling asleep? It's kind of the end of the whole thing, isn't it now? So we've got one more session, and then, well, thank you all for coming. It's been great to have you, and feel free to take the calculator off Yammer and take a look at it, and give me some feedback when you do. So thank you very much.